welcome to video 3. Today we're going to be looking at a problem called squares of a sorted array. Given an array of integers a, sorted in non-decreasing order, return an array of the squares of each number, also in sorted non-decreasing order. Okay, why don't they just say ascending? Pretty straightforward. All I would need to do is square these, and then when it returns back, I just need to sort them. Obviously, it's not going to be the most efficient, but for me to overcome my insecurities of algorithms, I just want to get it working. So yeah, I'm going to be gentle on myself and just do it that way. It's pretty easy. This is also an easy problem on LeetCode in the array section. So space is going to be O of 1. Is it going to be O of 1? And time is going to be O and log of n. And that's because we're sorting here. I think space is going to be O of 1 because I'm going to manipulate the array by itself. If I were to copy the array, it would be O of n, but let's just do O of n for now to be safe, and then let's try and change this to O of 1. So let's create an array and basically loop through a.length, or a, and basically what I want to do is sorted.push a I times 2 and return sorted dot sort a, b, a minus b. And the reason why I could come up with this is because I just know out of the top of my hand that this is the code to sort things in ascending order or non-decreasing. So I'm pretty confident with my code, but let's just run the code and see. Okay, it finished and it worked. And let's see if this was correct. All right, it got accepted. So pretty straightforward. The key was basically you need to square it, loop through it, and square it, which was here. And then basically, once you square it, you just sort it using JavaScript's native algorithm. Now, the price you pay for this is basically n log of n. That's the time complexity. So this is kind of like a good thing to talk about, is practicality versus time complexity. Now, if this was to be in production code, no way we're going to use n log of n. We'll try hopefully to make it faster with like O of n or like log n or something like that. But for simplicity's sake and to up your confidence, I think this should do. But let's take a look at it. Oh, look at that! Your written time beats 89% of JavaScript submissions. Interesting. So actually, this was faster than 90% of the people. So go me. Not entirely sure what other people do, but you can for sure go to like the solution and like a discussion to take a look. But let's try and make this O of n to O of 1. So I'm going to comment this out. And I'm going to go ahead and copy this code. Instead of push, I'm just going to do AI equals AI times 2, or power of 2. Could I do this? I'm not entirely sure, but whatever. Return A. And then dot sort A, B, A minus B. Let's see if this works. Because if this works, oh, it does. Okay, so that was a great example of first being 100% correct, but at the cost of O of n, and then dumbing it down to refine your code. And I'm pretty sure you're going to encounter that a ton when you are interviewing. But look at that, 8 to 14, 6 lines of code, and you can solve this easy problem. All you had to really know was basically, okay, I want to square them first, and then after that, after it's all squared, you just sort them. And that's what I did. Cool. Let me just double check one more time. 82%. Oh, okay. Well, anyways, cool.